Hello everyone, welcome back to ng.classes. I hope you all like my previous video, and if it helped you, please do subscribe my channel. And yes, if you want me to discuss any other topic, please comment in the comment box. So today we are going to discuss triangles. Here we will discuss the concept of congruency of triangle in detail. Apart from that, we will also discuss few theorems which are related to triangles. So let's start the discussion. Now let's see what's congruency of triangle. But before starting the discussion about triangle, at first we need to understand what's the meaning of this word congruency. So congruent means exactly same or equal in all respect. That means exactly same in shape and size. Now let's see some examples to understand it in detail. So here we are having two squares and we have to check whether these two squares are congruent with each other. That means exactly same with each other or not. So that means the measurement of this two square must be exactly same with each other. Now just by looking at the picture, it will not be fair enough to decide whether these two squares are same or not. So what we can do here is to just take the second square and place it on first square. Here we can see the second square is completely covering the first square. Or you can do it other way. You can take the first square and can place it on second square. If it will exactly cover the second square, then we can say both the figures are congruent with each other. Similarly, if we will see this shape, then here we can say, let's take the second square and place it on first. So here we can see the second square is not covering the first square completely. Hence, both the figures are not congruent with each other. Congruent means exactly same. Similarly, here we are having two triangles and we can check the congruency of the triangle just like the square only. Now here we can see the second triangle is covering the first triangle completely. Hence both the triangles are congruent with each other. Similarly, here we can say just by looking at the picture, it's not congruent because there is a variation in measurement of both the triangles. Now here two circles are there and the second circle, let's place it on first one and we can see the second circle is completely covering the first circle and hence both the circles are congruent with each other. And in the next example, these two are not congruent with each other. Now there are a lot of examples of congruent shapes in our daily life. One example can be whenever we are going to take photos, let's say passport size photo. So we get certain number of photos and all are congruent with each other, right? Similarly, another example can be whenever we have to buy a refill of any pen, then we must buy a refill which is exactly congruent with the older refill. Then only the new refill will get fit in the pen, right? Now you know what's the meaning of the word congruency. Now let's focus on congruency of triangles. So here we are having two triangles, triangle ABC and triangle PQR. Now let's check whether these two triangles are congruent or not by placing triangle PQR on triangle ABC. So when we will take triangle PQR and will place it on triangle ABC, here we can see that triangle PQR is covering triangle ABC completely. Hence, these two triangles are congruent with each other. One more thing we can notice here that the vertex P falls on vertex A, right? Can you see it? Here P falls on A, vertex Q falls on vertex B, and vertex R falls on vertex C. These are called corresponding vertices. Let's write it. P and A, vertex R and C overlap on each other, and vertex Q and B. Similarly, we can also see that side PQ falls on side AB, side PR falls on side AC, and side QR falls on side BC. These are called corresponding sides. Let's write it. PQ and AB, PR and AC, and also QR and BC. Similarly, we can see angle P falls on angle A, angle Q falls on angle B, and angle R falls on angle C. These are called corresponding angles. Let's write it. Now, if two triangles are congruent with each other, we can write it as triangle ABC. This is the sign of congruency, is congruent with triangle PQR. We must be careful while writing the sequence of the triangle. That means the name of the triangle ABC and PQR. Here the sequence of corresponding vertices, sides and angles must be written properly. That means vertex A and P must be a pair of corresponding vertices. Vertex B and Q also must be a pair of corresponding vertices, and C and R must be a pair of corresponding vertices. Similarly, angle A and angle P must be corresponding angle with each other. Angle B and Q must be corresponding angles with each other. And angle C and angle R must be corresponding angle with each other. Apart from this, we also need to check the sequence of sides. So, side AB must be corresponding side with side PQ, or both the side must be corresponding sides with each other. Side BC must be corresponding side with side QR, and side AC must be corresponding side with PR. So this way we will show congruency of two triangles. If you are writing triangle ABC is congruent with triangle QPR, then that must be incorrect, because here A doesn't falls on Q, B doesn't falls on P, and C doesn't falls on R. Now whenever we have to check the congruency of two triangles, and if the question is given in book or in exercise, then it's not possible to just cut out one of the triangle and place it on other triangle to check the congruency. That's why we will use the criteria for congruency of triangle. So let's see what are those criteria. Now let's take a triangle ABC where length of BC is given as 4 cm, and we have to draw a triangle which must be congruent to triangle ABC. So since we know only one length, the possibilities are we can draw one of the side of the triangle, let's say PQ, as 4 cm, and the other side can be like this. That's called triangle PQR. Or maybe we can also draw one of the side as 4 cm and can give it a name MN, and the other sides will be like this. Here we can see, just by knowing one of the side of the triangle, it is not possible to draw one and only one triangle which must be congruent to the given triangle ABC, right? Now let's say we know the other side also, that is side AB is 12 cm. Let's see whether we can draw a triangle which must be congruent to the given triangle ABC, where one of the side is 4 cm and another side is 12 cm. So here also we can draw a base which is of 4 cm and can draw the other side by making an arc of 12 cm. And we'll get a triangle like this. Let's say this is a triangle MNO. Now here also it is not possible to get one and only one triangle which must be congruent with triangle ABC. Now let's say we know all the three sides of ABC. So one of the side is 4 cm, another side is 12 cm, and the third side, that means AC, is also given as 13 cm. Let's see whether we can draw a triangle which will be congruent to triangle ABC or not. So let's draw the base of the triangle. We can draw the base of any length given. That means 4 cm, 12 cm or 13 centimeter. So let's draw a base of 4 centimeter only. Like this. Let's say the name of the base is RS, which is of 4 centimeter. Now, one of the side we need to take as a 13 centimeter, another side we need to take as 12 centimeter. So let's say 13 centimeter and let's draw an arc from the point R. We can take 13 centimeter in the compass like this. Now place the needle of the compass on point R. Let's make an arc like this. Now let's take other side measurement in the compass, that means 12 centimeter. Like this. Let's make an arc by keeping the needle of the compass on point S. Let's try to cut the previous arc. Here we need to extend the previous arc also. This way we will get the point of intersection. Let's say it's point T. Now let's join R and S with point T. Now this is our triangle RST, where side RT is 13 centimeter, side ST is 12 centimeter, and the base RS is 4 centimeter. And then we will rotate triangle RST and will place it over triangle ABC. We will find that the triangle RST will cover triangle ABC completely. Hence, these two triangles are congruent with each other. Please note, congruency means exactly same. Here we are allowed to rotate the shape while doing the comparison. Here side AB is congruent to side ST, side BC is congruent to side RS, and side AC is congruent to side RT. Hence, from here we can say the first criteria to check the congruency is if two triangles are there, then we can check whether all the three sides are same or not. If all the three sides are same, then we can say both the triangles are congruent with each other. And this is known as side congruence criteria. Like this, we are having few more criteria with the help of which we can check whether two triangles are congruent or not. Let's see what are those. Now, before starting the other criteria for congruency, let's see one example. So here our question says check the congruency of the given triangle. So let's see how many triangles we can see over here. We can see two triangles over here, right? Triangle ABD and triangle ACD. Let's write it. So here we are having two triangles, that is triangle ABD and triangle ACD. Now in this two triangle, we can clearly see in the figure that side AB is equals to side AC. Both are of 3.5 centimeter. And also side BD is equals to side DC, and side AD is the common side in both the triangle. So if side AD is of 5 centimeter in one of the triangle, in other triangle also its measurement will be same. Now from here we can see three sides of one of the triangle is same as three sides of the other triangle. Hence we can say both the triangle are congruent with each other by side congruent rule. Let's write it. That is triangle ABD is congruent with triangle ACD. Please note here the sequence also matters a lot. That means name of the triangle we must write it properly. So side AB must be equals to side AC. Side BD must be equals to side CD. And side AD must be equals to AD by side congruent rule. Now let's see criteria of congruency of triangle. The way we have learnt, side congruency rule. Like that, we are having few more rules. We will discuss it in detail one by one. So the second rule is side angle side congruency rule. Let's understand this rule with the help of one question. So here our question says we are having a quadrilateral ABCD where side AC is same as side AD already marked in the figure, and AB bisect angle A. So side AB is bisecting angle A. That means side AB is dividing angle A in two equal parts. Show that triangle ABC is congruent to triangle ABD. What can you say about BC and BD? Okay, so let's prove the congruency at first. Let's draw the triangle separately. So we have drawn the two triangles separately. Now here already it's given in the question that side AC is equals to side AD. Let's mark it. Side AC is same as side AD, and also AB bisect angle A. That means this angle and this angle will be same. So angle BAC will be equals to angle DAB. This is the given information with the help of which we have to prove both the triangles are congruent with each other. Now side angle side congruency rule says if two side of one of the triangle is same as two side of the other triangle, and also included angle between both the side of the first triangle is same as included angle between both the side of the second triangle, then we can say both the triangle are congruent with each other by side angle side congruency rule. So here we can see AC AB is same as AD and AB, right? Since AB is the common side, so if here it's 5 centimeter, in the other triangle also it will be 5 centimeter only, right? So two sides are same, and we can see the included angle between the two sides. We are not talking about the other angle, we are talking about the included angle between both the sides. Here the green angle which is included between both the purple side is same as the other green angle which is included between both the purple side. So let's prove it. We can say AC is equals to AD, already given in the question. Similarly, angle BAC is equals to angle BAD. That is also given according to the bisector condition. Now, side AB is same as side AB. That is the common side. So we can see here the sequence is side, angle, side. Hence, triangle ABC is congruent with triangle ABD. In bracket, we must mention the rule which we have used. So that is side, angle, side congruency rule. Now, the question is also asking about what can we say about side BC and BD. So as we know, when two triangles are congruent with each other, that means two triangles are exactly same with each other. That means their corresponding sides will be equals to each other, and corresponding angle will also be equals to each other. So we can see here side BC must be equals to side BD. Why? Because both are corresponding part of congruent triangle. In short, we write it as CPCT. That represent corresponding part of congruent triangle. Now let's see the next rule. So here the next rule is angle side angle congruence rule. Let's understand it with the help of given question. So here our question says L and M are two parallel lines. Here we can see in the figure also L and M are two parallel lines intersected by another pair of parallel line P and Q. So getting intersected by another pair of parallel line, that means P is parallel to Q, and we have to show that triangle ABC is congruent to triangle CDA. Let's draw the triangle separately. Here, since L is parallel to M, just remove this P and Q for a while. Okay. So here we can see if L is parallel to M, then AC works as a transversal line, right? And from here we can say that this angle must be equals to this angle, as both are alternate interior angle. If this is X, another one will also be X. Now since P is parallel to Q, so for a while let's remove LM and let's focus on the parallel line P and Q. Can you see P and Q as a parallel line? And here also AC works as a transversal line. So can we say this angle completely will be equals to this angle? Again, alternate interior angle. So if this angle is angle Y, here also we will be having angle Y only. Now if we will focus on two triangles, that means triangle ABC and triangle ADC, we can say angle BAC is equals to angle DCA, both are Y, and also angle DAC will be equals to angle ACB, both are X. So let's write it. Angle BAC is equals to angle DCA. We need to write the reason why these two angles are same, because P and Q are parallel with each other and this is alternate interior angle. Similarly, L and M are parallel to each other and again we are having alternate interior angle. And also here we are having side AC as a common side. Now see carefully, here we are having the sequence of angle, then side, then angle. Okay, hence we can say both the triangles are congruent with each other by angle side angle congruency rule. Please note, whenever we are proving the congruency, we must write the rule properly. And now our next rule is angle angle side congruency rule. Let's understand it with the help of one question. So our question says AD and BC are equal. So as we can see in the figure that side AD is equals to side BC and are perpendicular to the line AB. So both are perpendicular to the line AB as shown in the figure. Show that CD bisect AB. So we have to show that the line CD is bisecting the line AB. That means if the length of the total line AB is 10 centimeter, then OB will be 5 centimeter and AO will be 5 centimeter. So basically we have to prove that the length of OB is same as length of AO. Let's prove it with the help of the concept of congruency. So as we can see here, we are having two triangle AOD and triangle BOC. Now we can see here that angle O over here, that means angle AOD will be equals to angle BOC. Why? Because these two are vertically opposite angle, right? Let's write it. We can also see here that angle A, that means angle DAO is 90 degree. Similarly, angle CBO is also 90 degree, which is already given in the question. Let's write it. And now we can see that the side AD is equals to side BC. That is also given in the question. Let's write it. Now we can see the sequence that we have got one angle same, then another angle same, and then side same. We can also check it in the figure that angle, then again angle, and then side. So angle, angle, side, this sequence is getting maintained in the question. So we can say that these two triangles are congruent with each other by angle, angle, side congruency rule. Let's write it. Now these two triangles are congruent with each other. Hence all the corresponding sides and the corresponding angles will be equals to each other. So what are the corresponding sides? Here side AD and BC are corresponding sides which are equals to each other. Similarly, side OD and side OC, these two are also corresponding sides, and since these two triangles are congruent, so both the side will be equals to each other. Similarly, side OA and side OB are corresponding side and both will be equals to each other. So we can write OA will be equals to OB. Why? Because it's corresponding part of congruent triangles. And now our last rule is RHS congruence rule. Here RHS means right angle, hypotenuse and side. Let's understand it with the help of one question. So our question says P is a point equidistant from two lines L and M. So since P is a point which is equidistant from the line L and line M, hence we can say that PB is equals to PC, or the length of PB is equals to the length of PC. And we have to show here that the line AP bisect the angle between them. So the line AP is bisecting the angle between them. That means we have to show that this angle, that is angle PAB, is equals to this angle, that means angle PAC. Then only we can say line AP is bisecting angle A. Alright, let's do it. So here we can see two triangles. I am talking about triangle PAB and triangle PAC. Now in triangle PAB, we can see angle B is given as 90 degrees. Similarly, in triangle PAC, angle C is given as 90 degrees. So we can write it over here that angle PBA is equals to angle PCA. That is already given. Now we can see that PA and PA is common side in both the triangle. And also it is given that side PB is equals to side PC. Now let's see the sequence. So here we are having a 90 degree, that means right angle. After that we are having one side same. So that side, if you will see carefully the figure, is opposite to 90 degree. That means PA is hypotenuse for right angle triangle PAB and also for right angle triangle PAC, right? So we got a hypotenuse same and again we got one side same. So this is following the pattern of RHS, right angle, hypotenuse and then side. Hence we can write triangle PAB is congruent with triangle PAC by RHS congruency rule. And since we have to show that the line AP is bisecting angle A, since two triangles are congruent with each other, hence their corresponding sides and corresponding angles will also be equals to each other. So we can say from the triangle PAB, angle PAB is equals to angle PAC, and that's what we have to prove it, right? Hence we are done with the proof. Let's see some properties of triangle. So here our theorem says angles opposite to equal sides of an isosceles triangle are equal. We have already used this theorem while solving many of the questions. Here we are going to prove this theorem. So let's prove it. Let's say we are having a triangle ABC, and since the theorem says it's an isosceles triangle, so let's say side AB is same as side AC. Now here we will do one construction, and with the help of the concept of congruency, we will prove angles opposite to equal side are also equal. That means here angle B is equals to angle C. That's what we have to prove it. So let's say we have constructed a straight line AD which works as a bisector of angle A. That means angle BAD is equals to angle DAC according to the construction. Now here we can see two triangles, that is triangle ABD and triangle ACD. And also we can see in the figure that side AD is the common side in both the triangle, and angle BAD is equals to angle DAC by construction, and also side AB is equals to side AC already given in the theorem. Now from here we can see the sequence of side, included angle, and then side. You can check it in the figure also. We are taking the common side, then included angle, then other side. Hence we can say that triangle ABD is congruent with triangle ACD. Please check the sequence of the triangle. So side AB must be corresponding side with side AC. Side BD must be corresponding side with side CD, and side AD must be corresponding side with side AD by side angle side congruency rule. Now here we have to prove that angle ABD is equals to angle ACD. Since two triangles are congruent with each other, their corresponding part will also be equals to each other, right? So we can say therefore angle ABD must be equals to angle ACD. Why? Because it's corresponding part of congruent triangle by CPCT. Now let's see our next theorem. So the next theorem says the side opposite to equal angle of a triangle are equal. So this is just the converse of the previous theorem. In previous theorem, it was already given that we are having an isosceles triangle. That means two equal sides are there, and opposite to that we will get two equal angles also. Here we are having just the converse. That means here we are having equal angle, and we have to show that opposite to equal angle we are having equal side. So let's say it's a triangle ABC. Here we are having angle B is equals to angle C, which is already given in the theorem. So let's write it. Angle ABC is equals to angle ACB. That is already given. And we have to prove that side opposite to equal angle, that means side AC, must be equals to side AB. Now here also we will do the same construction like the previous theorem. So let's drop a perpendicular bisector. So let's say AD is the perpendicular bisector. Here we are having 90 degree, and here also we are having 90 degrees since we have dropped a perpendicular, and it also works as a bisector of angle A. So angle DAC is equals to angle DAB. And now we can see two triangles, that is triangle ABD and triangle ACD. In this two triangle, we can see that angle BDA and angle CDA is of 90 degree by construction. Side AD is the common side over here in both the triangle, and also since AD works as a bisector of angle A, we can say that angle DAB is equals to angle DAC, that too by construction. So here we got the sequence of angle, then side, then again angle. We can check it in the figure also that continuity is maintained. That means angle, then side, then angle. So we can say triangle ABD is congruent with triangle ACD. Let's check the sequence. AB must be corresponding side with AC, BD must be corresponding side with CD, and AD must be corresponding side with AD. By angle side angle congruent rule, and since these two triangles are congruent with each other, we can say that side AB must be equals to side AC by CPCT. That means corresponding part of congruent triangle must be equals to each other. Now let's solve one question which is based on the previous theorem. So our question says triangle ABC is an isosceles triangle. So let's focus on triangle ABC. So here the red triangle is an isosceles triangle in which AB is equals to AC. So side AB is equals to side AC. Here side BA is produced to D. So side BA is extended to D such that AD is equals to AB. So AD is also equals to AB. We have to show that BCD is a right angle. So this angle is of 90 degree. That's what we have to prove here. Now, since triangle ABC is an isosceles triangle where side AB and AC are of same length, can we say here angle B will be equals to angle C? Opposite angles will also be equal just by the previous theorem. So, if angle B is X, here angle C will also be X, right? Now, if we will focus on the other triangle, that means the purple triangle, here we can see this triangle is also an isosceles triangle. Why? Because already given in the question that side AD and AB are of same length. So from the question we are getting AB, AC, AD all are of same length. So this side is equals to this side. Hence, we can say this angle, let's say it's angle Y, will be equals to angle D. That means here also we will be having Y. Okay. Now, from the figure, we can see that angle BCD is equals to X plus Y. And if we will focus on triangle DBC, then we can say X plus Y plus X plus Y is equals to 180 degree. Angle sum property of the triangle. Recall that angle sum property of the triangle says sum of all the interior angle of a triangle will be of 180 degree. Now let's combine the like terms. So we are getting twice X plus twice Y is equals to 180 degree. And from here, if we will factor out 2, then we will be having X plus Y is equals to 180 degree. And from here, if we will shift 2 to other side, we will be having X plus Y is equals to 90 degree. That's what we wanted to prove, that this angle BCD is of 90 degree. That means X plus Y is of 90 degree we got, and hence we are done with the proof. And now we have few inequalities which gives few theorem for triangle. So inequality means either it will be greater than sign or lesser than sign or greater equals to or less equals to. These are 4 inequality sign. You must have done questions like 5 blank 6. That means 5 is smaller than 6, or -2 blank -3. That means -2 is larger than -3. Like this, we are having few inequalities in triangle. Let's see what are those. So here the first theorem says if two sides of a triangle are unequal, let's draw a triangle. Let's say it's a triangle ABC. Here, if two sides are unequal, that means let's say this one is 4 centimeter, this one is 5 centimeter, and side AC is of 7 centimeter. Now here, if two sides of triangle are unequal, we can take any two sides over here. Let's take side AC and side BC. These two are unequal. Then the angle opposite to the longer side, so AC, that is the longer side, opposite to that we are having angle B, right? So opposite to AC there is an angle B. Let's write it. Now here the theorem says the angle opposite to longer side is larger. So the angle opposite to the larger side must be larger than the shorter side. So opposite to BC we are having angle A. So here since AC is larger than BC, hence angle B must be greater than angle A. That's what the theorem says. We just need to understand the theorem. We don't have to prove it for now. Alright. Now here we are having one more theorem, and our theorem says in any triangle the side opposite to larger angle is longer. So this theorem is just the converse of the previous theorem. If we are having triangle ABC, if angle A is 105 degree, angle B is 30 degree, and angle C is 45 degree, then according to the theorem, the side opposite to larger angle will be longer. So the side opposite to larger angle, 105 degree is the largest angle over here, and the side opposite to that is the side BC. That side will be the larger side in this triangle. We can also arrange it according to the given angles. So 105 degree, that means angle A is greater than 45 degree, that is angle C is greater than 30 degree, that means angle B. So here we can write that side which is opposite to angle A, that means side BC, will be greater than side opposite to angle C. So angle C is having opposite side as AB. So according to the measurement of given angle, we can get which side is greater and which side is smaller. Now let's see one more theorem. So here our last theorem says the sum of any two sides of a triangle is greater than the third side. So let's say we are having a triangle ABC. Here side AB is of 4 centimeter, side BC is of 3 centimeter, and side AC is of 5 centimeter. When we will take the sum of any two sides, let's say we are taking the sum of AB and BC, that is 4 plus 3, will be greater than the third side, that is AC. And 4 plus 3 is 7. Obviously, we can see the measurement of AC is 5 centimeter and we got AB plus BC as a 7 centimeter. Similarly, if you will take any other side, that means AC plus BC. Let's take 5 centimeter plus 3 centimeter, which is 8 centimeter, and that is greater than the remaining side, that means AB. So 8 is greater than 4 centimeter. That is true and that's valid. If you will take any two sides of a triangle and will add it, it has to be greater than the third side. Then and only then we will get a triangle. Now let's say we are having the measurement of a given triangle as 4 centimeter, 3 centimeter and 9 centimeter. And we have to construct a triangle with the given measurement. You know how to construct a triangle with the help of compass. But here, when we will start constructing the triangle, we will find that it is not possible to construct a triangle with the given measurement. Why? Because sum of any two sides, if we will take the first side and the second side, that is 7, is not larger than the third side. This is not true. And hence we can say it is not possible to construct a triangle with the help of given measurement. So 3 conditions which must be followed, then and only then it is possible to construct the triangle is AB plus BC must be greater than AC. This is the first condition. The second condition is BC plus AC must be greater than AB. And the third condition is AC plus AB must be greater than BC. Now let's solve one question which is based on the previous theorem. So here our question says if PR is greater than PQ, here we are having a triangle PQR. Here the side PR is greater than the side PQ and PS or the line PS bisect angle QPR, as we can see in the figure. This angle and this angle are equal with each other as PS works as a bisector. Prove that angle PSR, that means this angle, is greater than angle PSQ, that means this angle. Alright, so let's prove it. Before starting the discussion of our proof, let's understand one thing about inequality. So whenever we are having an inequality, let's say we are having 5 greater than 3. That is true, right? This inequality sign is valid over here. Here we are allowed to add same term or same number on both the side. So even if we will add 5 plus 1 and here also 3 plus 1, we don't have to change the inequality sign. Still we will be copying greater than sign only because we know that 6 is greater than 4, right? So whenever we are adding same term on both the side, there is no changes in the inequality sign. Similarly, we can subtract same term from both the side and it will not give any impact on the inequality sign. So 5 is larger than 3. Here if we will subtract 5 minus 2 and on the other side also if we are subtracting the same number, that means 2 only. So we don't have to change the inequality sign. As we can see, 5 minus 2 is 3 and 3 minus 2 is 1. Still, the left hand side is larger than the right hand side. Same thing goes for multiplication and division also. Whenever we are multiplying same number on both the side, we don't have to change the inequality sign. But we have to be careful that we are multiplying or dividing by a positive number. Because once we will take the negative number, let's say again the same example, 5 is greater than 3. And if you will multiply or divide by a negative number, let's say you are multiplying both sides with minus 2. So 5 multiplied with minus 2 and 3 multiplied with negative 2. So 5 multiplied with negative 2 became minus 10 and 3 multiplied with negative 2 became minus 6. Now here you can see minus 10 is not greater than minus 6. Rather minus 6 is greater than minus 10, right? So we have to reverse the inequality sign in this case. So whenever we are multiplying or dividing any inequality by a negative term or a negative number, we have to reverse the inequality sign. Greater than sign will change to less than sign. Less than sign will change to greater than sign. If greater or equal sign is there, it will change to less or equal sign. And if less or equal sign is there, if it will get reversed to greater or equal sign. Now let's get back to our question. So we have to prove that angle PSR is greater than angle PSQ. Here we know that PR is greater than PQ. Let's write it. Since side PR is greater than side PQ, can we write the angle which is opposite to PR? That means angle Q will be greater than the angle which is opposite to PQ. That means angle R. Let's write it. Now it is also given in the question that PS acts as a bisector of angle QPR. So since PS bisect angle QPR, then we can write that angle QPS is equals to angle SPR. Let's say this is equation 2. Now if we will take equation 1, that is PQS is greater than PRS, And now only we learned that in an inequality, we are allowed to add same term on both the sides. So let's add this term over here and this term over here, because both are same only, right? Since we are adding the same thing on both the side, inequality sign will continue as it is. And this is our equation 3. Okay. Now let's focus on triangle PQS. Can you see green color triangle? Yeah. So in green color triangle PQS, here this angle PSR works like an exterior angle, right? We have extended one of the side. So PSR, that is exterior angle, is equals to sum of two interior angle. We are having this theorem, right? PSR is equals to sum of angle PQS plus angle QP. Please note, we are just focusing on green triangle. This is our equation number 4. Similarly, let's focus on the other triangle, that means triangle PSR. Alright. So here we are talking about the other triangle, that is triangle PSR, the purple triangle. Here we can see this angle, that means angle PSQ works like an exterior angle. Again, we will apply the same theorem. That means exterior angle PSQ is equals to the sum of other two interior angle. Angle SRP plus angle RPS. This is equation number 5. Now, when we will focus on equation number 3, let's focus on equation number 3. Can you see the rectangular part? We are having angle PQS plus QPS. In equation number 4, the value of PQS plus QPS is angle PSR. So let's write equation number 3 at first, that we are having PQS plus angle QPS is larger than angle PRS plus angle SPR. I have just copy pasted equation number 3. Now here I will replace left hand side by using equation number 4, that is angle PSR, because this completely is equals to this. And similarly on the right hand side, PRS plus SPR. So this is what we are having in equation. Please note SRP and PRS is the same term because we want to indicate angle R only in both the cases. So here we will use equation and will write angle PSQ. And now see carefully, we wanted to prove this only. That is angle PSR is greater than angle PSQ. And hence we are done with our proof. I hope the whole concept on triangle is clear to you. Stay tuned for the next video. Thank you.